Hello guys, welcome on Tesla Adventures. In this video today, we are going to discuss the concepts of the moving perpendicular direction of projectile to the initial direction. So you can see that this is a projectile which is being fired at an angle of theta from the horizontal, and we need to find out the time at which it would be moving in the perpendicular direction of the initial direction. So we need to find out the time taken by the projectile to move from this point to this point. Okay, so what we do, and obviously this is possible only when theta is greater than 45, because we know that if theta is less than 45, then projectile, obviously we know that projectile will strike at the ground at the same angle theta. So let us suppose that if theta is 30 degree, then it would again strike at 30 degree. So the angle would become 0 initially, and then it would be becoming 30 degree again. But to move perpendicular to the initial direction, the angle of, if this is 30, then when the time at which it would be moving perpendicular, then this angle would be 60, which could not be possible because theta is less than 45. So for this to occur, we should remember that theta should be greater than 45 degree. So I am discussing this phenomena with three different methods, and at the end of this video I would be recommending the method which you should use in order to save the time. So you can see first of all that in this case, let us use the first method. In this case you can see that the initial velocity u initial in the vector form is equal to u cos theta, or I can say that ux I cap plus uy j cap, and at this point of time the velocity would be, this is ux itself and this is vy. So v at the final time would be ux I cap minus vy j cap. Okay, so this is the velocity at the final time. Or you can, again, what you can do is the fact that you can take this positive sign and you can ignore that it is in the downward direction, and now you can write down the value of vy. So the value of vy would be equal to uy minus gt, that is the time. So v is equal to ux I cap plus uy minus gt j cap. Now what would we do? We would be using the concept that u dot v would be 0. So by multiplying these two, that we can see that this would be ux square, this is ux square, and plus it would be vy into it would be uy into uy minus gt, uy minus gt. Okay, so you can see that it is 0, it should be 0. So ux square plus this is uy square minus uy gt should be equal to 0, and you can see that it is this is u square, and u square is equal to uy gt. Now uy is u sin theta into gt, so t will be equal to u upon g sin theta. So this is the time that it would take to move perpendicular to the initial direction. Now let us discuss the method 2. In this method 2, you can see that we know that if this is initially projected at an angle of theta, then obviously at this point of time this angle should be 90 minus theta, because in that case this u, which is projected at an angle of theta, then they both would be perpendicular to each other. You can see that the angle between u and v in this case is 90 degree. Okay, so what you can see that the component of v in this direction is v cos 90 minus theta, which is v sin theta, and v sine theta should be equal to u cos theta, because the x component of velocities always remains constant. So v is equal to u cot theta. Now vy. So vy is equal to v cos theta, and therefore we can say that the time taken the time taken by the projectile to be moving with this velocity in the downward direction is vy is equal to uy minus gt, and vy is minus v cos theta. Okay, and this is uy is u cos, in fact u sine theta, and minus g into time t. So gt is equal to u sine theta minus v is u cot theta, so this is u cos square theta by sine theta. Okay, you can, this is plus. So you can see that if we are taking LCM, then this time would be equal to, t will be equal to u, this is u is common, and cos square plus sine square would be 1, and this would be u upon sine theta. So time will be u upon g sine theta, which is the same result which we have got from the method 1. Now we will discuss the method 3, which is, I think, which is the most best method, and this is also a method which makes us learn a new concept. So let us discuss this one. So let us examine the motion on this line OP. So you can see that the initial on OP, on line OP, initial velocity is u, obviously, and the velocity and the acceleration of gravity is g in downward direction. So the component of acceleration, see, this angle is 90 minus theta and this angle is theta. So the component of acceleration along this line is g sine theta. This is g sine theta. So the acceleration on this line would be minus g sine theta, because u and g are opposite. So what we will do, that the final velocity on this line, v final, is 0, because there is no component of this velocity along this line. So v is equal to u plus at, and v is 0 and u is u, and this is minus g sine theta into t. So t will be equal to u upon g sine theta, which we have already got. So I think this is the best method which has taught us that how to solve the projectile on some other line. So this was all in this video, and in the next videos we'll be bringing more concepts of projectile. Thank you.